Have you ever stopped to think if artificial intelligence really understands what it means to be human, or if it is just processing data in an impressive way? In this video, we'll explore the fascinating history of AI, its capabilities and limitations, and how it impacts our everyday lives. Get ready for a journey that will question everything you know about machines and intelligence, and discover whether we are closer to true understanding or just sophisticated algorithms. Stay with us and dive into this thought-provoking debate. The history of artificial intelligence, AI, dates back to the mid-20th century. The concept of machines that could simulate human intelligence began to take shape in 1956, during the famous Dartmouth Conference, where researchers met to discuss the possibility that every aspect of learning or any other characteristic of intelligence can, in principle, be described so precisely that a machine can be made to simulate it. Since then, AI has gone through several phases of enthusiasm and disenchantment, known as AI winters. In the 1960s, research focused on solving specific problems in games like chess. However, hardware limitations and the complexity of the problems caused progress to slow down. In the 1980s, the emergence of neural networks brought a new impetus to research, but it was still an era of unfulfilled promises. The big leap occurred at the beginning of the 21st century, with the exponential increase in computational capacity and the availability of large volumes of data. These factors, combined with new algorithms, enabled the development of deep learning models, which transformed AI into a reality present in our daily lives, from virtual assistants to recommendation systems. But what exactly is artificial intelligence? In simple terms, it is the ability of machines and computing systems to perform tasks that would normally require human intelligence, such as reasoning, learning, perception, and understanding language. AI can be divided into two main categories: narrow AI, which is designed to perform specific tasks, such as speech recognition or medical diagnosis, and general AI, which has the ability to understand, learn, and apply knowledge across a wide range of activities. Narrow AI is the form we see most today, such as personal assistants, recommendation systems, and even chatbots, which help answer simple questions. On the other hand, general AI is still a theoretical concept, as machines cannot yet replicate the complexity of human reasoning at all levels. By understanding these categories, we realize that AI does not attempt to fully replicate human intelligence, but rather to forge efficient solutions to problems facing humanity. This distinction is fundamental to understanding the capabilities and limitations of AI in its current state. Early advances in artificial intelligence brought to light both promises and limitations. In the 1950s and 1960s, the development of programs that played chess and solved mathematical problems was satisfactory, but machines faced enormous difficulties in understanding natural language and complex contexts. For example, while a program could beat a chess champion, it wouldn't be able to understand an everyday conversation. In the 1970s, AI became stagnant, with the so-called first era of AI failing to deliver promising results on a large scale. Researchers quickly learned that despite their advances, machines do not penetrate deeply into the nuances of human behavior and cognition. However, the following years brought significant innovations, such as the use of machine learning algorithms, which allow data analysis in a more autonomous way. The arrival of so-called big data and the creation of deep neural networks have created new opportunities for AI, leading to a renaissance in the sector over the last decade. This has currently enabled AI systems to develop functions ranging from facial recognition to the generation of natural language, expanding the scope of their applicability in everyday life. One of the most significant advances in the evolution of artificial intelligence is the development of natural languages. This subarea of AI focuses on enabling machines to understand and interact with humans through a language that both can understand. Natural language is, therefore, a field that unites linguistics, computer science, and artificial intelligence to improve communication between humans and machines. One of the main challenges here is that human language is full of ambiguities and contexts that machines, due to their logical nature, have difficulty interpreting. This field includes a series of tasks, such as sentiment analysis, language translation, and even text generation. As technology advances, AI tools have become increasingly sophisticated, making interacting with virtual assistants like Siri and Alexa feel natural and intuitive. However, even with these innovations, the question arises, To what extent can AIs truly understand the meaning behind words, or are they just processing patterns in a vast network of data? The answer to this question is not simple and raises debates about the essence of understanding and the nature of intelligence. To understand how artificial intelligence processes information, it is necessary to start with the structure of data processing. AI works in layers, starting with collecting data, which can come from different sources, such as texts, images, and interactions with users. This data is then organized and stored in databases. The first step in information processing involves cleaning and preparing the data, removing noise and inconsistencies that could harm the results. From there, the data is separated into training and testing sets. The training set is used for the AI to learn to recognize patterns, while the test set is used to evaluate the effectiveness of learning. Once these sets are ready, AI uses algorithms to begin the learning process, adjusting its internal structures as it absorbs the data. In other words, the processor acts like a student, who in each class or data acquires new information that will help in solving problems. This structure allows AI to become capable of performing specific tasks, but it is important to note that, despite appearing intelligent, it still follows a programmed logic, which does not match the complexity of human cognition. Thus, the structure of data processing within AI reflects an organized system, which seeks efficiency in its operations, but not necessarily in terms of understanding or accurately interpreting the world around us. Algorithms and machine learning are the heart of most artificial intelligence systems. An algorithm, in this context, is a set of rules or instructions that the machine follows to perform a task. There are several types of algorithms, each designed to solve specific problems. Machine learning, on the other hand, is a branch of AI that allows machines to learn from data, improving their performance over time. It operates in a similar way to the way humans learn, where trial and error are part of the process. Through machine learning, AI can identify patterns in large volumes of data and predict outcomes based on these patterns. This is particularly useful in areas such as medical diagnosis, where the machine can learn to identify diseases from medical images. Furthermore, there are different approaches within machine learning, such as supervised learning, where the machine learns from examples with labels, and unsupervised learning, where it looks for patterns in data that have not been previously labeled. This flexibility makes machine learning a powerful tool for everyday applications, but it also presents challenges as machines can be influenced by biases in the data they are learning and consequently replicate these biases in their decisions. Neural networks are a fundamental component in the field of machine learning. They are inspired by the functioning of the human brain and consist of a set of nodes, or neurons, that work together to process information. A neural network is made up of layers: the input layer, hidden layers, and the output layer. The input layer receives the data, while the hidden layers perform the processing, adjusting the connections between neurons through weights that are modified during learning. When the network is trained, it adjusts based on the information it receives, optimizing its ability to make predictions and recognize patterns. This model is applied in several areas, such as image recognition, automatic translation, and even art creation, demonstrating the versatility of neural networks. However, the complexity of neural networks also brings challenges. For example, the difficulty in explaining the decisions that AI makes is growing, as it becomes a black box, making it difficult to understand the processes that lead to a specific result. Therefore, although neural networks are an incredibly powerful tool, transparency and interpretability in AI-generated decisions remain a significant concern. The limitations of current AI processing are crucial factors to consider, especially when reflecting on your true understanding of meaning. Despite advances, machines still have difficulty understanding complex contexts, emotions, and nuances of human communication. A simple example is the ambiguity present in language. A machine can interpret a sentence literally, without capturing the tone or intent behind the words. Another important aspect is that AI depends on existing data. If this data contains errors or biases, the results generated by AI will also reflect these problems, leading to unreliable conclusions. Furthermore, an AI's decision is based on statistical patterns, not on a deep understanding of reality. This raises ethical questions about the application of AI in areas such as criminal justice and hiring, where decisions can significantly impact lives. Furthermore, Even in the simplest tasks, such as answering questions, AI may fail to provide correct answers in new or little explored situations in its training data. Therefore, it is evident that, despite its impressive data processing capacity and effectiveness in many areas, AI still has limitations that distance it from true human understanding of the world, highlighting the complexity intrinsic to intelligence and interpretation of meaning. To understand the difference between understanding and processing, it is essential to first address the concept of understanding within the context of artificial intelligence. Understanding, in the human sense, is a complex experience that involves interpretation, meaning, and context. For us, understanding means assimilating not just the words we hear or read, but also capturing the emotions, intentions, and nuances behind them. When someone tells us a story, for example, we not only understand the facts, but we also emotionally connect with the characters and their experiences. On the other hand, in the context of AI, understanding is much more limited. Let's consider an AI that has been programmed to recognize patterns in text. She can identify keywords and identify a predominant feeling, but she is unaware of the emotions these words evoke in humans. Therefore, when defining understanding in AI, we reflect that it is a simulation of understanding that lacks the emotional depth and awareness that we as humans naturally possess. This distinction is critical as it emphasizes that while AI can process information quickly and effectively, it cannot. Now, let's explore concrete examples of how AI can process data without having true understanding. A very common case is the use of chatbots in customer service. These systems are programmed to answer frequently asked questions. When a customer requests help, the chatbot searches its database for matches to provide an answer. For example, if someone asks, "How can I return my order?" the chatbot can respond with return instructions. However, while the response may seem appropriate, the chatbot does not capture the desperation or frustration the customer may be feeling when dealing with a return issue. It processes the data and generates a response, but does not understand the situation in an empathetic way. Another example is sentiment analysis in comments on social media. There are AI systems that can detect whether a comment is positive, negative, or neutral, but this identification does not reflect true understanding. The AI does not understand why a person is sad or happy, but only groups emotions based on words and phrases. Thus, we see that AI is excellent at manipulating data, but this manipulation does not translate into understanding it in a human sense. This leads us to question the fundamental limitations of AI in simulating human feelings and experiences. To deepen this discussion, we can bring to light even more examples of processing without understanding. A relevant example is machine translation. Translation systems, such as Google Translate, use complex algorithms to translate texts from one language to another. If someone types, "I love flowers," the system can process it and translate it into English as "I love flowers." However, this translation does not take into account the cultural context that may be linked to the phrase. The expression of love for flowers can have various connotations in different cultures, and AI does not understand these subtleties. It simply switches words from one language to another. Another example can be observed in systems that generate automatic text summaries. These systems can create summaries that condense important information, but without understanding what is most relevant to readers. While a human can identify the key points of a text based on deeper understanding and nuances, AI tends to do this based on word frequency alone. These situations highlight the discrepancy between data processing and true understanding. Even if AI demonstrates efficiency in performing these tasks, a lack of emotional or contextual understanding is a significant barrier that limits its usefulness in more complex situations. Another crucial element in the discussion about human understanding versus AI processing is the role of emotion and empathy. We, as human beings, are deeply guided by our emotions. The ability to feel compassion, joy, sadness, and other feelings allows us to create meaningful connections with each other. For example, in conversation, if someone shares a personal story of loss, our response is not just verbal, it's emotional. We can offer comfort, understand suffering, and connect with what the other person is going through. AI, however sophisticated it may be, does not have feelings or the capacity for empathy. When programmed to respond to emotions, as in psychological support software, AI can identify patterns in what someone is saying, but its responses are based on data and algorithms, not the real human experience of understanding pain or joy. Therefore, although interactions may seem natural, they lack the depth that comes from emotional understanding. This is a critical challenge for AI, as true understanding involves not only logical processing of data, but also the ability to connect emotionally, something machines cannot do. Thus, we recognize the importance of empathy in human communication and understanding, something that AI cannot currently replicate. The awareness of artificial intelligence is an issue that generates a lot of discussion among scientists, philosophers, and researchers. Over the years, several theories have emerged about whether machines can achieve some kind of human-like consciousness. Some argue that once an AI reaches an advanced level of complex processing and interactions, it would be reasonable to consider that it could experience a form of consciousness. On the other hand, critics argue that consciousness involves subjective experiences and feelings, something that machines, being only systems based on algorithms and data, cannot authentically experience. In this line of reasoning, what would consciousness be if not the ability to feel and reflect on lived experiences? This debate intensifies especially when we approach the idea of a general AI, which would have abilities to understand and apply knowledge in a broad way, perhaps even surpassing human abilities. However, how far can machines truly become conscious? This is a question that remains open and continues to challenge the consolidated understanding of what it means to be conscious. Understanding the concept of consciousness, especially in the context of AI, must take into account not only what machines can do, but also the human nature of consciousness itself and what makes it unique. The debate over whether AI should be considered a mind or a tool is a central question in the discussion about its impact on our society. Those who see AI as a mind suggest that as technology evolves, AI will develop a capability similar to human cognition, becoming an intelligent partner in everyday tasks. This vision offers a promising horizon for the use of AI, where intelligent machines could actively collaborate with humans, improving our efficiency and expanding our capabilities. However, this perspective is contested by experts who argue that AI should be seen strictly as a tool. In this sense, AI does not have emotions, intentions, or desires and therefore cannot be considered our equal. These voices point to the need to keep a critical eye on the role of AI in our lives, emphasizing that, no matter how advanced they become, machines are built to serve human purposes and must be controlled by us. This debate is crucial to shaping policies and practices that ensure AI brings benefits without harming fundamental human values. Case studies of AI in practical use have become increasingly common and reveal both the potential and limitations of the technology. In sectors such as healthcare, for example, AI is being used to aid medical diagnoses, analyzing large volumes of data to identify patterns and predict diseases. This not only improves diagnostic accuracy, but also allows doctors to make more informed decisions. However, the effectiveness of AI depends on the quality and diversity of the data used to train it. Another notable example is the field of education, where AI can personalize learning experiences. Adaptive learning tools help students progress at their own pace by offering individualized support. While these examples demonstrate the practical uses and benefits of AI, they also raise important questions about technological dependency, data privacy, and the need for human oversight. Those responsible for implementing these systems are challenged to balance the effective use of technology with ethics and social responsibility, ensuring that AI serves to improve lives without compromising fundamental rights. The criticisms and ethical challenges related to AI are topics of great relevance today. As technology becomes more prevalent in society, concerns about data privacy and security increase. The massive data collection required to train AI systems raises questions about informed consent and the ethical use of this information. Furthermore, the potential for bias in AI algorithms is a significant criticism that cannot be ignored. Systems built on biased data can perpetuate inequities and discrimination in several areas, including recruitment, credit, and criminal justice. Another ethical challenge involves the transparency of decisions made by AI. The complexities of deep learning algorithms often make it difficult to understand how an AI reaches a conclusion, creating a scenario where decisions can be viewed as black boxes. To ensure that AI is developed and used responsibly, experts advocate the need for clear regulations and guidelines that address these and other ethical concerns, promoting an inclusive debate about how to shape the future of AI in alignment with human values. The field of artificial intelligence is constantly evolving and new trends emerge every day, signaling a promising future, but also full of challenges. One of the most notable trends is the advancement of explanatory AI, which seeks to make machine decision-making processes more transparent and understandable to humans. This is especially important in critical areas such as healthcare and justice, where decisions made by algorithms need to be justifiable. Another emerging trend is the use of AI in collaborative work environments, where humans and machines interact to optimize processes and increase productivity. Furthermore, there is a growth in AI applications in creative areas, such as art and music, where algorithms are being developed to create works that challenge our conceptions of authorship and originality. Personalization and user experience are also hotbeds of innovation, with increasingly refined algorithms capable of anticipating users' needs. With these trends, the relationship between people and machines is becoming more integrated and complex, requiring careful reflection on ethics and responsibility when implementing AI into our daily lives. The AI-driven work revolution is transforming the job market in ways few could imagine. With the automation of repetitive and administrative tasks, many jobs are at risk of extinction. However, on the other hand, new opportunities arise that require skills complementary to what machines do. Professions focused on data analysis, maintenance, and programming of AI systems, and services that require emotional intelligence and creativity are increasingly valued. This transition is a call for workers to adapt and update their skills through training and continuous learning. For women over 50 in particular, the challenge can be alarming, but it can also be seen as a chance for professional reinvention. Requalification programs and initiatives that encourage a return to the job market are essential. Furthermore, adapting to highly digital environments can open doors to new careers that take advantage of experience and networks, valuable characteristics for any professional. By embracing these transformations and cultivating an open mindset, it is possible to build a new future where collaboration between humans and machines is not only viable, but also desirable. The future vision for artificial intelligence is one that combines human and artificial intelligence, leading to a new era of augmented intelligence. This collaboration between man and machine has the potential to expand our cognitive and emotional capabilities beyond what we thought possible. Imagine a world where AI helps us understand complex information instantly, suggesting innovative and personalized solutions, a time in which we learn from data intuitively and effectively. This can be particularly beneficial in fields like healthcare, where technology and empathy must go hand in hand. Here, AI can process vast amounts of clinical information, identifying patterns and suggesting diagnoses, while doctors maintain the human connection essential to their decisions. This symbiosis promises not only efficiency, but also more human care, amplifying the ability to solve complex problems in an innovative way. However, this vision brings to light other issues, mainly ethical and social, that cannot be ignored. We need to ensure that, as we move in this direction, technologies are developed responsibly and are accessible to everyone, avoiding social inequalities and empowering the most vulnerable communities. The future of AI is not just about smarter machines. It's about creating a better world for us all. When we reflect on the future of artificial intelligence, multiple scenarios emerge that deserve our attention. On the one hand, we can find a universe where AI becomes an indispensable tool in everyday life, improving the quality of life and enhancing human capabilities. In this ideal scenario, AI applications will help solve global challenges such as disease, poverty, and climate change, giving individuals more time and resources to focus on what really matters. However, it is also necessary to consider the risks that accompany this evolution. Without adequate regulation, we could be faced with a world where AI amplifies existing biases, results in job losses and invasions of privacy. The issue of data security and privacy is becoming increasingly pertinent, raising necessary debates about how information is collected and used. There is the possibility of dystopian scenarios, where the autonomy of human beings is compromised and machines govern decisions. The important thing is that, As a society, we play an active role in shaping that future. By promoting an open and inclusive dialogue about the use of AI, we ensure that innovations are aligned with our real needs and values. This way, we will have a better chance of ensuring that artificial intelligence does not just process data, but truly understands and contributes to the common good. True understanding goes beyond simply processing data. While artificial intelligence can perform impressive tasks, understanding the meaning behind human words and emotions requires empathy and awareness, characteristics that machines do not yet possess. We're curious to know, what kind of story would you like to hear in our next video? Share your ideas and suggestions below. Given AI's limitations in understanding meaning, do you believe we should be more concerned about greater reliance on this technology, or is it a tool that can be used beneficially? Leave your opinion in the comments. Don't forget to subscribe to our channel so you don't miss the next video, where we will explore more about the innovations and challenges of artificial intelligence. Your participation is important to us.